So ladies and gentlemen, Mason is here, and today we are going to be setting up the MAX6675 and MAX31855 thermocouples with the STM32 Nucleo F446RE board. Basically, this is a thermocouple board that allows you to connect thermocouples to it, and then they decode or like convert the voltage difference between the two thermocouple leads into the desired digital output signal that you are looking for, that your Nucleo or any other microcontroller can process. So let's jump right into it. This tutorial is very relevant in terms of the latest updates, because if you don't know, ST just changed all the previous things that rendered most, like probably 99% of or 98% of tutorials irrelevant, meaning that the previous ones cannot be really used because the new interface that the MX, the CubeMX and the IDE is separated into. And basically from 2.00 you can use this because the latest versions are going to be still like this. First of all, MPU selector, this we don't care about this because you don't want to select the chip but the board itself, because this is a pre-built board. This is the board selector. You choose this, you find the board that you are looking for here, you write your own here and then start project. Yes, initialize everything. You will see that window here in a quick moment, and then we are going to put this full screen. So what we want is, first things first, let's examine a board. We will have a VDD, whatever VCC, whatever they call it, the power, the ground, and 3 connectors. These are usually called MISO, CS, and HCK. These are all required, and the MAX6675s are usually driven from 5 volts, but the MAX31855s are usually driven from 3.3 volts. So keep this in mind, because you don't want to connect the MAX31855 to the 5 volts. What we first have to do is that we will come in here, and I have already prepped this. Basically here we can see the pins. I'm not supported by this side, but I usually use this because in the documentation here that there is only the we'll cover this, but there is not that lovely, or I haven't found these lovely things as labels. So what I was using on my board is the going to go down, is going to be the pins called PB13, 14 and 15, because as you can see, this is very small here, SPI2, this is the MISO, this is the MOSI or MOSI, and this is the HCK. So we're going to use the HCK, the MISO, and we are going to use the PB15 as the CS pin. If you don't know about this, the most important thing is that the SCK gives the board the clock, and so that it is, if I understand it correctly, that it is synced, and we can ask for the data, because it gives us packages back in ordered bits, so that we can read it. But nonetheless, it is not that relevant how it is coming in. It might be relevant when you are debugging it and you don't know what the problem might be. But the most important thing is the SPI HCK is there to give the board a clock. The MISO is there to communicate, so receive the bits. And the CS is that it is like a drive pin that basically sends out voltage constantly, sends out a constant high 1 signal to the temperature sensor board, and when it sets to low, basically when it switches to 0, then the data can be read and the data will be transmitted back through the MISO pin from the board itself to the STM32. So these will be very important and relevant later when I will talk about it. Just hang around. So I have found these pins here. These you can choose the other ones. There are multiple ones. I would strongly suggest, if you are starting out, that you use the PA5 pin. It will give you one more extra feature that you might know, that PA5 is linked internally to the green LED, which will be very useful because when the board needs to, as I said, toggle toggle off the CS pin, which is this, we will use the SPI2 pins just like I do, like the 13, 14 for the HCK and for the MISO, and then use the PA5, the LED pin, as the CS. This is that because so we enable these two for the MISO and the CS, and this basically, as I said, needs to send out a 0 value so that the board can send in the data, meaning the temperature data, in like a specific format. When the pin is toggled off, then it basically drives the LED at the same time. So when you set this to a constant high as a baseline, so that it is safe and doesn't read garbage data, then it will basically light up and it will be illuminated, meaning the LED. But when it is toggling off, then you will be able to see it toggle off. Also, this is only for debugging, because you will need to adjust the switching a bit, because it will be so very little like dims in it that you will not be able to see, because it is so fast. It does it in like a few microseconds when it is toggling it off, so it would look like a continuous on. But nonetheless, you would be able to see if there is any errors with the LED or the PA5. This is basically enabled. But let's set this up to these pins that I have wanted to. We will enable the SPI CS or SCK. We will enable the MISO, SPI2 MISO, and this will be a GPIO output. That is, we send out constant one. We would need to come here in connectivity. We'll go into SPI2, and this is why it is yellow, because it is currently not enabled. You would have to set it to a full duplex master, otherwise it will not work. And trust me, I have tried with the receive only masters or master, and I would say I have and didn't waste, but I would say I have hardly struggled with this for about 5-6 hours till I found out that this was actually the problem, not misfiring, nor that the CS wasn't toggling on or off, or the MISO was floating, but actually that the receive only master was not adequate for us to have a full and seamless communication between the board and the MCU. So full duplex master, and basically here you want to set the data size, and all these things are good. What you need to go here is that to change this to 32 or 64, but 64 is probably preferable. It is kind of nice and slow, and you want to keep this. So basically this is setting 0, which is low, and 1 edge. This can fuck the whole thing up if you set this to 2 edge or set this to high, because this determines when the communication is happening. You want to keep the C pole and the CPH as they are, and you don't want to change anything besides this here. So yeah, yes, so very important for duplex master and 64 as a prescaler. This is very, very important. So then we would come in here and go into not the analogs, but here into the GPIO. I always forget which thing is it. So GPIO, here we have already see the PB15, pin PB15, and we will pull this up, and we want to set it to a high. As I said, we want it to have a baseline of 1, so that the temperature sensor board will never send us anything except when we ask for it, and that will be determined on the clock, so that we have meaningful data, not just garbage coming in all the time. So this way it is safe and it is integrally sound. Push-pull is fine. Maximum output speed is, I think it should be very high, but I don't think you need to change anything here other than this. So this is fine. Call it T1, because I will use multiple, but you can leave them here as well. T1, this is going to be the SCK, this is going to be the MISO or MISO, and this is going to be the we don't call this, we are going to call it enter user label. You can do it as well with ts1cs ts. So we will have these are all nice. These will be go here into the project managers, as it always sets itself to this shit, so make sure that you set it, because otherwise it will not work properly. So CubeIDE, I don't know why it resets itself when you download some bullshit. So basically we want to set the toolchain, because this is like another error that I have wasted like 2 days for to find this out. So this needs to be set, otherwise the CubeIDE will not recognize the file, you will not be able to find it and edit it at all. So generate code. Yeah, it can be done in my case, because the other thing is that it doesn't find the project location. Yeah, that's the thing actually. I'll save it here. I mean, I did created a projects file, but it doesn't really matter. Test 3 generate code. So now it is working. We will generate the code, and we will have to create 2 folders, as you can see here. It will be probably also will need to import the new file if it is done. Open import. We will import a CubeMax IDE bullshit directory. Very lovely that it always fucking forgets it. Okay, I think it should be test. Where the fuck is this? Projects test 3. Okay, finish. We'll have this here. It doesn't have anything just yet, so it's not that big of a deal. So test 3. We'll have to open the core, Usher C, main C, and we will have to include now we will have to also add, because it doesn't recognize it. I think it is in the project properties, if I can remember. It is in general settings. Yes, here settings. Here you have to add it. Just code in the miscellaneous here. See. So yeah, print this underscore printf underscore float. Okay. Apply close, and it will rebuild index. Don't care. So it will now work. Regardless, we have to build the things in here, which will be, because as you can see we have this MAX6675H, and we don't have it here because we need to click on here. New. This is the C, so we need a C type project here, source file. We will call it MAX6675.c, and great, we don't have jack shit in this. Have to print this thing out. Control, you can control almost A them. We'll give it into the description. We'll control C it here. Control close max, and we will have to make this H as well. So we need the max. If you have this or that, it doesn't matter, the same things. If you have the MAX31855, you can paste the whole thing into there. Just you remember that you cannot use this for that, so you cannot overchange them. You need the same library as your Max chip is, because otherwise it will not work, because as I said, it requires, or like it accepts a certain type of format of bits that it receives, and it will decode those, and the 31855 will differ from the 6675. Yep. Open this. We will only need to control C this, because these 2 lines and the end if will be given to us. So we have to create this as well, but not in the Usher C, but in the ink, because here are the H ended files. So we create this header file H, and we will paste here the MAX6675.h. Will be generated. As you can see, as I said, here the beginning and ending is given. We only have to paste this shit into the middle, and then we'll be able to finally open the Usher C, main C of the main file. So this is the whole backbone of the code. These are like the libraries that we can call, that we have just made the H and C ended ones. We can include them like so. Before anybody freaks out that the STM32 is only 3.3 volts and you should not allow like 5 volts into the, because MISO is when it is communicating with the STM32, it signals at like specifically for the MAX6675, it is VCC minus 0.04 or something like that. That is like 4.6%, 4.6, 4.5 volts. And you might ask, but isn't that going to fry the board? No, because what we have here, you can see and read it here, that IO structure, these pins that are FT or FTF signed are 5 volt tolerant IO ports, and guess what? Most of the ports are FT tolerance or 5 volt tolerance. We will be able to find this. EB 13, 14 and 15 are all 5 volt tolerant pins, so we have no problem, nothing to fear. So I will include the code, and then we are basically, this code is specifically for to print out into a window. If you have any other than MATLAB, you will have to set it up in that, if you have Python or something like that, but I think the console printout will be the same. So basically you put the plugin, you upload the code. I have already tested it out, so it was working. That's why you can see the things, but you actually first build it, the hammer, then you click run. You will have a pop-up window to select the test 3 of your version, because mine is test 3, but yours will be called different. But click on this, it has basically put the file on, shutting down exit. When you see this, it has already uploaded onto your board. Now you can use your thing. Mine is MATLAB, but whatever you might use. I think it uploaded back the old code. This one, you have to set this out. Check test 3 debug, upload this, because I think it has uploaded back the old code, the big one, this one, the main one that I use. No problem. Oh, it's actually writing it out. Okay, great. So we have here the values. Okay, good to know. So now it is running, and as you can see, we have the time here. It is okay. If it would not be, then it would 0, and this is realistic. If I were to take a lighter and going to put a little flame under the pin or the thermocouple, and as you can see, it went up to 42 degrees C. So yeah, that confirms that it is working. So yeah, common problems. First of all, you didn't connect the pins in the right order. You change them up, so they are either not connected to here properly or onto the board. You swapped up the different pins. One. Second, that you didn't first of all enable this, but when you do the pin out, you should basically always set the SPI2 to full duplex master, as well as set the GPIO here, the CS, which is PB15, set it to always high, so it is a high. That is a problem as well. If you don't do it, it will not work. Very useful tool is a multimeter. So if and as well as I said, use the PA5. So when and also you will need to add a bit of delay into the code, like 50 milliseconds. It will maybe fuck with the timing a bit, but it's still going to be running fine. So that basically we will be able to see if it is the CS toggling off and on, that is very important, and see the MISO is floating on or off. The codes will be included in the description. So thank you for watching. Do the hard work, especially when you don't feel like it.